Okay, so we have a data set here given in Excel with number of family members and the pounds of trash this family produces in a year. This is made up, but it's based off of what I found online, just FYI. Okay, so the table shows the number of family members given in a household along with the number of pounds of trash they produced last year. Use this data to answer the following questions. So we are dealing with hypothesis testing here in Excel. So number one, we want to test that the pounds of trash produced is less than 4,000 pounds. So based off of that, what is the null and alternative hypotheses? So remember that the null hypothesis, we'll call that HO, and then HA for the alternative. Well, the HA is pretty easy to find, right? We have a sample here, and we want to talk about less than 4,000 pounds. So I'm just going to use X is less than 4,000, right? There's my alternative hypothesis. And then I know that my null hypothesis is going to have the equal sign in here. So we're going to call this greater than or equal to 4,000. Because if our alternative hypothesis is less than, then our null hypothesis is greater than or equal to. Now we need to find the test statistic. So if you remember, the test statistic is found by taking X minus the mean divided by the standard deviation, which is divided by the square root of the sample size. Whew. So X in this case is going to be 4,000, but we need to find the mean, the standard deviation, and the sample size. So let's go ahead and find the mean of the trash. So mean, we can do that by taking equals the average. And I'm just going to click on the first one and drag, right at the bottom. You can also just type in the cell references B2 to B30. And I have my average. Then I need my standard deviation. So I'm going to equals S, and we need stet dev S because this is a sample. So again, B2 to B30. I'm going to need my sample size. So if you don't know your sample size, you can use the equals count. And again, just how many are in here. It'll tell us that the sample size is 29. Now, eventually we are going to need the degrees of freedom. So we know that the degree of freedom is 1 less than our sample size because we are dealing with a one sample test. And is that all we need? Well, let's go ahead and just find the standard error. The standard error is the standard deviation divided by the square root of n. Square root of n. Thank you. I forgot to put parentheses around my square root. Okay, so that's just the denominator, right? The standard deviation divided by the square root of n. So when I want to find my test statistic, I can type in my formula equals X, which is 4,000, minus the mean, there's my numerator, divided by the standard error, which is the standard deviation divided by the square root of n. And I get my test statistic. Now we need the test statistic so that we can do our test. Now I know from what I'm given here that if we draw our normal distribution, because my null hypothesis is X is less than 4,000, I am looking at a left-tailed test, right? So that's what we're looking for here. So because it's a left-tailed test, and this is a sample, we are going to be using a T distribution. So you'll notice we have T distribution two tail, right tail, or just the T dist. If you're doing left tail, that's kind of the default. So we just want T dist. Now you'll see you're asked three things. First, we need X. X is our 4,000 because that's what we're testing. Then we need our degrees of freedom, which we know to be 28. And is this cumulative? Do we want the distribution function or the probability density function? Well, we want the distribution function. So we're going to use a 1. And, oh, that's not what's supposed to happen. Time out. Y'all, this is not 4,000. This is our test statistic. It's like it's my first day. I don't know what's happening. So that's why we find our test statistic, because that is the test statistic that we are testing in this sample. So I can click on, and that gives me my p-value. So this is the p-value. Now you'll notice it's E to the -5. That means we would move the decimal 5 places to the left. So 4 zeros and then 21836. So you're comparing the p-value to your alpha of 0.05. Now, because our p is less than alpha, right? If our probability value is less than our given alpha, right? If the p is low, the hoe must go, right? That's what I always say. So we can reject the null hypothesis because the p-value is less. So we reject the null hypothesis. If you reject it, that means we can accept that the number of pounds of trash is less than 4,000 per family. That's what that says. We can accept that based off this data. Because the p-value is less than alpha, we can reject the null hypothesis, which means we accept. It doesn't prove that it's true. We can just say we don't have enough to say that it's not. All right, let's go to the second one. So number 4, we want to test that the number of family members is greater than 3. So we're going to need this same information, but we're going to need it for the family members. So let's go ahead and find the average. So we're going A2 to A30. The standard deviation, again, this is a sample, so stet dev S. We know that the n is 29, we know the degree of freedom is 28, and the standard error is the standard deviation divided by the square root of n. Okay, so I have that information. Now let's answer the questions. Null and alternative hypothesis. So the alternative hypothesis, we are talking about greater than 3. So that means our null hypothesis is going to be, where's my, there we go. Excuse me. Our null hypothesis is going to be less than or equal to 3. So again, based off of this piece here, I can say, well, I look at my alternative hypothesis, it's greater than 3. So we're looking for a right-tailed test, just FYI. So again, let's find the test statistic. So x, which is 3, minus the mean, divided by the standard error. And we get our test statistic. So now I can do my t-distribution, and it's a right-tailed test, so I use right tail. The x is our test statistic, and then we just need our degrees of freedom, which is 28. And we can see, again, this is our p-value. Now our p-value here is way greater than alpha, right? Alpha is 0.01. So because our p-value is greater than alpha, we cannot reject our null hypothesis. Therefore, we cannot say anything about the number of family members being greater than 3. So because we cannot reject the null hypothesis, right? The null hypothesis is that x is less than or equal to 3. We can't reject it. That doesn't mean that it's true. It just means that we can't prove that it's false. And so therefore, we cannot reject the null hypothesis, and we cannot accept that the number of family members is greater than 3. That's just where we're at. So that is how we can do hypothesis testing for a sample in Excel.